Making sense of data, and this really is pretty huge later on in life, that if you look at what's on the ACT, I'm more used to, but now they switched to the SAT, at least for a few years, but it's this test you'll take junior year in high school. It tests to see how good you are. Often it'll help you for like college scholarship kind of stuff. The science section is mostly being able to interpret tables and graphs. So it's fairly important for scholarships and that kind of stuff. And just a lot of times if you go through, like, used to be the newspaper, but now online, they'll do things on graphs that make the data look very different sometimes than what it is. It's what they do with the axes and things like that. So being able to interpret the data from graphs is a fairly helpful life skill that'll get you places. So we're going to do really just the two things in here, and I'm actually starting with the second I can statement on your sheet. I'm going to start with the bar graphs. So bar graphs. And with these, I'm going to write down a couple bullets. You could kind of skip writing those if you want to. It's really kind of up to you. I guess it's not really bullets, a star. Fancy bullet. Okay. Uses bars to show numerical or number data. So uses bars to show, and you really could skip writing these if you wanted to, but numerical, or by that we mean like number data. So basically we're taking and we're having bars then that are going to somehow represent like numbers of things. And if you have a larger number, the bar should be longer, shorter? Yep, longer. So longer bar equals a larger number. And perhaps what I should have started with, the whole like picture is 1,000 words, kind of like let's just draw one and kind of go with what it looks like. But if we look around the room, so let's count up our number of people. So we have 4, 5, 6, 7 girls. So we have 7 girls. So we'll do like girls. We'll count you. So we have 8. So we have girls, and we have guys. So for girls, I'm just going to write down a 7 so I don't forget it. Guys, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 of us guys. So our graph has to go up to 8, right? Often when I'm making numbers, I'll start with even numbers. So if I had 9 being my total, I maybe would have like be 10. So as if I do 8 there and 0 at the bottom, right in the middle is going to be 4. And then you could do like 5, 6, 7, something like that. So 6 should be right in the middle. But now for girls, we had 7 girls. So the bar for girls then should go up to the 7. So I make my top. So this then here would be like the bar that represents the number of girls in class. Then the bar for guys should be taller, shorter?
Blue. Well, taller. Blue.
Taller. And see if I can find a blue. So guys then should go up to that 8 mark. So something like that. Let's see if I can take off the very top edge. It looks like I'm a little bit high on my 8. So something like that maybe. But that'd be like an example of a bar graph. Sometimes they call it a column graph. I wouldn't bother trying to quick do this, but you could do the same thing but have it go the other way. So they could put girls here and guys. I wouldn't draw this one. I'm just going to try to go real fast. But then you could have the guys going off to the side that way and the girls going this way, not quite as long. So they could do it that way, then throw some numbers over here, 2 and 8 and 0 and so on. Work for you? So that's the bar graph. The nice part about bar graphs is you can real quickly look at something and see, okay, which one's bigger, especially if you have a whole bunch of different numbers. So number 2 is a circle graph. Anybody remember the food name that sometimes they call it? Go for it. Yeah, pie graph or a pie chart is how I heard it. I'm going to start with a picture. That's probably how I should have done it before. But if we were to, so I'm going to scroll down a little bit and try to do my example down here, and then you could choose if you want to write some lines up above it describing it. But if we were to do that same thing, the people by gender, it's up to you. You don't have to, I don't think. But what they're going to do is they're going to take the whole amount would be like the whole circle. So if we have 8 guys and 7 girls, we need to take this thing and cut it into, technically it'd be like 15 even wedges. And for that you're going to end up with something like a little bit more than half, that's probably a little bit more aggressive than it should be for an angle. That's about the same thing, but it'd be like, so you could say, all right, we have this many guys in the room, so this many guys, and then go back with a purple again for the girls. You have this many girls. So you can see that there's more guys than girls, because the guys have a little bit bigger of a wedge than what the girls do. Is that fair? And then, if you wanted to kind of write out what it is, here's kind of my explanation. And if you don't think this is going to be helpful, I wouldn't bother writing it down. But it's a circle divided into wedges. So a circle divided, a little bit sloppy, into wedges. That show how a set of data compare to the whole. So we have the whole being like the total number of people in the room, bless you. And we're looking at, okay, the set of that. How does the set of guys compare to the whole number of people in the room? Or how does the set of girls compare to the whole number of people in the room? Any questions on those? So it's not officially notes. We'll probably start Monday with doing like page 6. We'll work through an example, and then we'll turn you loose on the homework. So, have a great day. There's probably a lot of truth to that.